Mathematica is a very useful tool for higher level mathematics and STEM courses, but getting started with Mathematica can be intimidating, especially if you don't have a coding background. Today I just want to show you the basics of how to get started with Mathematica so you can tackle more complicated problems down the road. I've opened up a new Mathematica notebook, and I do want you to be aware that Mathematica uses .mb files, that's notebook files, that combines word processing with live calculations. So you can actually write a paper or a presentation in Mathematica and let your calculations be done in live time, which is pretty impressive. Alright, so let me show you several aspects of what Mathematica can do. We'll start with just being a basic calculator, and Mathematica can handle pretty much any sort of calculation that you want to do, just like you would in a calculator, like 9 plus 8 minus 7 to the 45th power, and it can compute very quickly. And the way you execute a calculation is by hitting Shift and Enter together. So you have to do that every time. We can even do things like factorial and many other types of calculations. I'll show you some more as we go. Now, a powerful thing about Mathematica is its ability to name. So pretty much anything in Mathematica can have a name. And once you give it a name, Mathematica will understand what you're talking about. For example, if I say a equals 7, and then I want to say something like 3 plus a, Mathematica understands that I mean 3 plus 7. And it doesn't just work for variables like we did here, but we can do other things. We can name functions. So I can name an f of x function. Let's just say we want to define f of x to be something like x squared minus 1 plus square root of x. Okay. Now this is incorrect the way I have it, and I did it this way on purpose because I want to show you when you're naming a function. So I want Mathematica now to understand that f of x is this function here, x squared minus 1 plus square root of x. I need to, inside my, where I define f of x, I need to put an underscore after my variable, and notice all the x's turn green. That lets Mathematica know that after the equal sign, the x represents inputs. Okay, so now if I say something like f of 3, it knows exactly what I'm talking about. Or how about f of a, because remember I defined a to be 7, it knows exactly what I'm talking about. And it will keep up with what f of x is, which is very nice. Another thing we could do, if let's say we're going to graph f of x, I could label it b, and I'll explain how to do plots a little later, just bear with me for a moment. Here I have a graph that I call b, and anytime I hit b, and Shift Enter, it knows I'm talking about the graph of my f of x function. All right, so that's very helpful. Now also let me mention that you can define multiple variable functions as well. So for example, if I wanted an x and a y, all I have to do is put in an x and a y into my inputs, and now anytime I have x squared and y squared, or if I want x times y, notice that when I wrote xy it's blue. In an algebra textbook, xy means x times y. And Mathematica, xy may be a new variable. So let's put an asterisk in between to denote that I'm talking about x times y. And now I have a new function, so I can just plug in any point I want, about 1, 1, and it gives me my value, and so on. Naming functions is a very, very useful tool. Okay, now a tip that I have is when you label a function or you give something a name, avoid using capital letters. The reason is that all the built-in functions in Mathematica are capitalized. If you forget a capital letter, it will not work. Okay, so it's best to let your own labels to be lowercase and keep the capital letters reserved for Mathematica functions. So speaking of which, let me show you some common functions that we have available to us in Mathematica. So here are some of our most common functions that we use in terms of calculations, okay? And so I have them here listed in this column. In, square root, sine, sum, in sum. And notice I did put the brackets because I want you to understand that for a Mathematica function to work, it has to have hard brackets. And so here's another tip to keep in mind. When you see brackets in Mathematica, that is reserved specifically for function inputs. Parentheses is grouping things. So when you have multiplication, or you're trying to keep your numerator and your denominator as one thing for syntax, parentheses is used there, and then the braces or the squiggly brackets are reserved for lists and parameters. All right, now let me just quickly give you examples of what all these things do. So for example, if I say the square root of 5, we already saw something like this earlier. We get the square root of 5, but I want to know a decimal place. That's where the n comes into play. Okay, now here's another tip. I'm going to embed a function inside my n function, which is totally valid. So the way I do that is I work what I say outside n. So let me show you again. So first of all, there's my decimal. There's the square root of 5 to 5 decimal places, 2.23607. Let me show that again, because typically we write from left to right, but here in Mathematica I don't want to do that. I don't want to write this completely left to right. I want to write the n function, open and close my brackets, and then move the cursor inside there to type in my square root of 5. The reason I do that is because when you have a bunch of nestled functions, it's very easy to miss a bracket or a brace somewhere, and then you spend a long time trying to track down where you got it wrong. So if you work outside inside, that'll help clarify a lot of that. Okay, now going over a few more of these functions, if I have all the trigonometric functions for me, I just wrote sine there, but I could do cosine or whatever I want. So let's say I want to take cosine of pi. Pi is capital Pi. Cosine of pi over 3. There it is, 1/2. If I said cosine, or let's say tangent of pi over 2. Oh, complex infinity, that means it's undefined, okay? If I do tangent pi over 6, I get 1 over root 3. But if I want the decimal expansion of that, I can just put the n function around it and get my decimal value, all right? Summation is a very useful function. If I want to sum a bunch of things by a formula, let's say I just want to sum I going from 1 to 10. So this is like the series notation that you would see in maybe a calculus course or something. I'm adding up values 1 to 10. It will quickly give me 55. If I do something like this, sum of cosine of I squared, I going from 1 to 10. So this is adding up cosine 1 plus cosine 4 plus cosine 9, so on, just like we have here. That gives me the technical expression, but it's not what I want because I want the decimal values. I could put the n function around this and it will calculate the numerical value, or I could use the n sum function, which is basically like combining those two functions together. And there it is, I get the same thing. So the n sum function is basically the n function around the sum function. They're going to be useful. And notice here in the sum and n sum functions, I used braces, the I 1 to 10. Those are my parameters, and different functions require different types of parameters, and it really just is a matter of just getting used to them to know when and what to put in. Here, this is like an index. I'm summing up things that look like I, with I going from 1 to 10. Alright, let me show you some more common functions. This time we're going to look at some algebraic functions. So Mathematica can also manipulate algebraic expressions, which is very neat. So for example here we have some functions solve, insolve, factor, simplify, expand. We can do these kind of things. So I can solve an equation, an algebraic equation. So maybe like something like this, x squared plus 5x plus 6. Now be careful, when you are trying to type in equals for an equation, if I just say equals 0, that's going to create some sort of weird memory issue because now I'm defining x squared plus 5x plus 6 to be 0, which is not what I mean. I want to solve the equation x squared plus 5x plus 6 equals 0. So you put double equals in there for equals when you're talking about in the context of an equation. And now the solve function needs to know what variable we're solving for. So we're going to solve for the variable x like that. I'm going to hit Shift Enter. Look at that. I get -3 and -2 as my solutions. Pretty cool. So we could use insolve to solve an equation where we need to use some sort of decimal expansion. So maybe like the square root of x equals 1.1x. And we want to solve that for x. And here we get a values of 0, of course. And then we get a decimal value of this 0.826446. All right. So let's try insolve on cosine x equals sine x. When does that happen? Okay, now remember, trig functions are periodic. Okay, so they can repeat. So we're going to get a lot of answers here. And we get these weird looking things, conditional expressions, where you have, it looks like something like this. This -2.3 plus 6.28 C1, where C1 is an integer. This is like some sort of set builder notation for an infinite number of solutions, which is not exactly what we want. So there's another function that actually lists in the table here that's very useful. Maybe find root. So let's try this. Let's find root. And maybe in the context of our question, we want x to be, we don't care about all integers, but we want x to be close to a certain value. So maybe we can say, x is close to the number pi. What kind of solutions can I get close to that? So I hit Shift Enter, and there it gives me x is 3.92699. This pi here is kind of the starting point. That's kind of where I want to look to find cosine x equals sine x. So if I change it, let's say to 0, I get another value because there's another root close to 0 there. Okay, now these other functions that we have here deal with manipulating algebraic expressions. So let me start with expand, even though it's at the bottom of my list. So watch what we can do here. Let's say we want to expand out x minus 1 times x plus 4 times x minus 17 times x plus 8. Okay, we're going to expand that out. I don't know exactly what that is, but there it is. There's the polynomial of doing all that multiplication for us. Okay, now the reason I did that is because that's going to help me find an example to use the factor. So if I use factor here and I type in the expression that I just got, notice that I go back to what I had. I have the x minus 17 times x minus 1 times x plus 4 times x plus 8. So it factored this expression for me, which is very useful. Okay, now similarly, simplify and full simplify can help you reduce an algebraic expression that may not completely factor, but maybe we can clarify it a little bit. So for example, if I do simplify x to the fourth plus 5x cubed minus x squared. So when I run simplify on that expression, notice that it did factor it. It took out the x squared, but you still have this quadratic. Okay, so maybe if I try full simplify on the same thing, it'll try a little harder. And notice it didn't do a lot, but inside my quadratic, it factored out an x where it could. Okay. Okay, now I already showed you one kind of plot, and I want to show you plotting again. Okay, and plot can get pretty complicated, so I'm not going to go through all the details here. There are tons of them, and you can look online to find things. Let me just get you started. Okay, so let's define a function. Let's say x plus 1 divided by x squared plus 3. Okay, and I want to plot this function. So what I do, I use the plot function. So that's capital P, and I'm going to put my brackets in. Now what I want to plot is my function f of x, and you need to specify, so there's some parameters. The parameters are the independent variable, which is the x here, and then a range. So why don't we go from 0 to 5. Shift enter, and there it is. There's my graph, 0 to 5 right there. Okay, sometimes we want to plot multiple functions together. So the way you do that is you just make a list. List is with braces of f of x, and then let's think of, how about sine x squared, and how about let's throw in there x cubed minus x plus tan x. All right, and we want to go, I don't know, let's go from -3 to 4. And so now I have 3 functions. It should plot all 3 of them there together, and there it is. The blue is the first one, the yellow is the second one, the green is the third one. And you can see those vertical asymptotes. Mathematica denotes those with those straight vertical lines in the green right there. Okay, so that's how we can plot a function and then plot multiple functions together. Another thing you should see is how to do a list plot. So let's say we had a set of points that I'm going to call D. How do you do points? Points are actually lists themselves. So for example, I might have the point 0, 1 and -1, 1, and let me get a few other points. All right, so there's my list, and notice that I have each point is a list itself, and then I put that whole thing in a list, and I labeled it. Okay, so now what I could say is I'm going to do a list plot on that set of lists. So list plot D, and there it is. There are the points that I listed out. Now what may be useful is that you want to show this data set with one of my curves. Okay, so how do you do that? Because this is a list plot, it's a different function than like what we did here. So what I'm going to do now is let me label this thing my list plot, and let me come up to f of x up here, and let's call that my plot. And so I want to show those two things together. I want to show that plot and my list plot together. The way you can do that is by using the show function, and you just call them by name. So I want to show my list plot and my plot. just like that. So there are my two plots together. Right now, depending on your data set and your function, they may match up a little bit better, but that's just the example we picked. All right, let me show you one common problem people will do a lot, and this is kind of going back to some of my tips. So let's plot sine from 0, or let's go from negative pi to pi, and I don't get anything. I get a blank graph. All right, now the reason this is wrong is because the sine function here is not a defined function. Notice it's lowercase s. To make it a defined function, I need capital S, right? Built-in functions get capitalized, and there it is. Okay, so that goes back to my points that I was talking about earlier. Remember, built-in functions are always capitalized. If you're getting an error statement, that could be one of the reasons you're getting one. Also remember my other tips to work outside to the inside when you're writing these out. So don't try to write just plot, bracket, sine, bracket. It's very easy to misplace a parenthesis, a brace, a bracket, and not know where it's coming from. If you work outside, inside, it'll help reduce that error. And then also remember that brackets are reserved for functions. Parentheses are reserved for grouping, like in algebra statements. And braces are reserved for lists and parameters. This will get you started with Mathematica. There is a ton of stuff to do out there. If you need help with it, I'd be glad to help. Just let me know, leave a comment, and I'll try to help. Alright guys, good luck and have a lot of fun with Mathematica. It's an incredible tool. Thanks for watching.